We'll start today by looking at prime factorization. Remember that a factor is any value that you multiply to gain a product, and that prime numbers are any numbers that can only be divided by themselves and 1. So if we're looking for prime factorization of a number, that means that we're looking for all of the prime numbers that you multiply together to get this value. So the number we've got right now is 924. What I always tell people to do is check the first 5 prime numbers: 2, 3, 5, 7, and 11 for divisibility. Sometimes you have to extend to 13 and 17. One of the first clues is to look for things like even numbers, something that's divisible by 5 or by 2. Those are really easy to see. To test if something is divisible by 3, you just have to add up your values. So this would be 9 plus 6, which is 15, and 15 is divisible by 3. So this is divisible by 3 also. So those are just some clues that you can look for. This value here, 924, I know it's an even number. I make it sort of into a factor tree, and I say that this is 2 times 462. 462 is another even number, so this 2 stays here, and this becomes 2 times 231. I have no more even numbers, so I can check to see if this is divisible by 3. Since this should be 2 plus 3 plus 1 is 6, so I can divide this by 3. And when I do, this 2 stays the same, that 2 stays the same. This becomes 3 times 77. And then I know that 77 is 7 times 11. I strongly recommend that when you're doing prime factorization, you organize the factors from smallest to largest so that you can see what's happening. Prime factorization really is the first step in finding the greatest common factor of values and least common multiple of values. Before we go into a lot of detail what those things are, let's get prime factorizations of the 3 numbers we have. So we are finding both greatest common factor and least common multiple for these values. So for 100, if I get the prime factorization, I know that 100 is 10 times 10, so that makes this 2 times 2 times 5 times 5. For 120, I know that 120 is 12 times 10, so that becomes 2 times 2 times 2 times 3 times 5. And then finally I've got 90. That's 9 times 10, 2 times 3 times 3 times 5. For greatest common factor, what I'm going to do is I'm going to look for values that show up in both, or not both, in all 3 numbers. So I have a 2. So I write down 2. What you notice is that you do not have that second 2 here. So you can't count a second 2. We don't have a third 2 in either one of these places. If you look here for the 3, you've got a 3 in 2 of them, but not in this one here. So you can't count that 3. The next value that exists in all 3 is a single 5. So the greatest common factor, that means it's the largest number that you can divide 100 by, 120 by, and 90 by. I can do 100 divided by 10, 120 divided by 10, and 90 divided by 10. Least common multiple is a little bit harder. What I do with least common multiple is I take my first set of prime values and I list them out. And then I go to my next set of prime values, and I cross out anything that's been used. So I've got a 2 here, and I have a 2 here, so I can cross out a 2. I've got a second 2 here, so I can cross out a second 2 there. But notice I don't have a third 2 here. There are 3 2's here, which means that I need 3 2's over here. So I will add that in. Then I look, there's a 3. Do I have a 3? There are no 3's, so I need to include a 3. And then there's a 5. I've got a single 5 here, which means I can't replace that 1 5. Now I've finished with the factors of 120. I move on to the factors of 90, and I start from the beginning. So there's a 2, here's a 2. I have to cross out one of these 2's. There's a 3, I've got a 3, so I have to cross out the 3. Here's a second 3. There is no second 3 listed over here, so I have to include that. Then I go back, I've got a 5, here's a 5. This is why I tell you to list these values in order. So now, this is the prime factorization for the least common multiple, and this value is 1800. This is the smallest number that I can divide by 100. So I can do 1800 divided by 100, 1800 divided by 1200, 1800 divided by 90. We can do the exact same thing even when there are variables. So on the first one, prime factorization of 32, that's 2 to the 5th power. There are 3 x's and 3 y's. For 120, I know that that is 3 2's, a 3, and a 5. I've got a single x and 4 y's. And then for 42, I should have included that this was xy to the 4th. For 42, x squared y cubed. 42, that's 7 times 6, so that gives me 2 times 3 times 7, 2 x's and 3 y's. And then I go through the exact same process. For greatest common factor, I find all the things that they have the same. So here's a 2. There's another 2 here, but I don't have a second 2. I definitely don't have a third 2 or a fourth 2 or a fifth 2. So I'm done with all my 2's. If I move on to x's, I can see there's an x here. There's no second x going on here, so I can't use any of these. So I can move on to the y's. There's a y. That's 2 of them. 3 of them. So I have 3 y's. So what I can write down, I circled 2, x, and 3 y's. So that's 2xy cubed. Now I do least common multiple. So I'll write down the entire prime factorization for 32x cubed y cubed. And then I start. I've got 5 2's. 1, 2, don't have any more 2's, so I don't have to cross out 2's from 120. but I don't have any 3s, so I have to tack on a 3. I don't have any 5s, so I have to tack on a 5. But I do have 3 x's, so I have to cross out an x. And I do have 3 y's. 1, 2, 3. There's a 4th y right here, so I got to tack that onto the end. Now I move to the next one. There are 5 2's. There is 1 3. There's a 5, which I don't see here, but here's a 7, so I need to tack that onto the end as well. And then when I start looking at x's, again, I've got 3 x's here, so there are 3 x's, and I've got 4 y's, so 1, 2, 3. So now I'm done. And now I start to collect all these values. This is 35 times 15 times 7. I calculate that to be 3,360. I've got 3 x's here, so that's x cubed. And then I've got 3 plus 1 more y, that's y to the 4th. I quickly want to go over some special cases. You have your perfect square trinomials, which you saw last time. A plus b quantity squared, this is what it looks like. You need to have this pattern memorized. A minus b quantity squared looks like this. You need to have it memorized. A difference of squares, a squared minus b squared. We do a plus b and a minus b. This must be memorized. The last one, sum and difference of cubes. I want you to recognize it when you see it, and I want you to be able to follow the formula, but I don't expect you to memorize this one. Now we're going to start factoring. This is the opposite of foiling. It's like foiling backwards. And really what you're doing is you're looking for the numbers that you can factor out, so the greatest common factor of each term. Please understand, I do not expect you to write out prime factorization and circle things and all of that stuff. I expect you to simply be able to recognize what's happening. So when I start with this first problem, I know that there are 3 x's happening here and 2 here. That means I can factor out 2 x's. There's a 3 here, and this is 15, so I could factor a 3 out of this. So what that looks like is I know I can say 3x squared times what will be left over here. If I divide by 3x squared, well, I'll be left with a single x. And then when I look over here, what will be left over when I divide by 3x squared? I'll be left with just 5. So this is now factored. If you can't see this, then you will need to write out prime factorization. So you're looking for the greatest common factor of each term, and you're going to divide each term by that factor. So now we look at some special cases. I've got y squared minus 49. That is a difference of squares. So I know when I have my 2 binomials, I'll have y and y. The square root of 49 is 7. One of them will be added, one will be subtracted. Looking at this one, this is a sum of cubes. Now I did tell you you were not obligated to memorize the formula, but you had to know how to use it. So this is the formula. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Now I'm going to tell you this right now because a lot of you are going to say, well, isn't this just a perfect square? No, it is not. If it was a perfect square, there'd be a 2 here. So for our sum of cubes, in this case, I could rewrite this as a cubed, that's easy enough. 8 is 2 cubed. So a is a, but b is 2. So this gives me a plus 2 times a squared minus 2a plus 4. Sometimes we do what's called factoring by grouping, meaning we're going to put things together that have the same kind of terms that we can factor out. You have a few options with this one, but for what we're looking at here, I'm going to group together like this. So from the first set, I see that I can factor out an x. So that gives me x times y plus 5. And from the second one, I see that I can factor out a 3. So that gives me 3 times y plus 5. Now what we can do is combine the two factors to give us x plus 3, because both x and 3 are being multiplied by y plus 5. Right? There's your y plus 5, y plus 5. It's only because these are the same that I can put these two together. Now for the last one. This is a special case that I do expect that you're going to be able to recognize. I've got some perfect squares going on here. One thing that a lot of students forget is that 1 is a perfect square. It's also a perfect cube. So when you factor this, I always set up my 2 sets of parentheses. And what I can see is a squared. So that's 2m squared. And then 2ab. So that's 2 times 2m times 1. And then b squared is 1 squared. So here's what that's going to look like. I have 2m and 2m, 1 and 1. If I wanted to check this, 2m times 2m, that's 4m squared, plus 2m plus 2m, that's 4m plus 1. The last section is on factoring quadratics specifically. So if I look at the next one, x squared minus 2x minus 8. What I do is I always set up my parentheses. I know that the first term will be x because it's x squared. The next thing I do is I look at my constant. Because this is a negative, what that tells me is that my signs are going to be different. I'm going to have a minus and a plus. It doesn't matter which order you put them in. Then I start looking at factors of 8. They don't have to be prime factors, they just have to be factors. So I have 1 and 8, I have 2 and 4. Those are the whole number factors of 8. So then I start to think, well, if I multiply these, I'll get 8. I need to be able to add them to get negative 2. So negative 1 plus 8, not negative 2. Negative 8 plus 1, not negative 2. Negative 2 plus 4, not negative 2. Negative 4 plus 2, that is negative 2. So what that tells me is 4 has to be the minus sign, 2 has to be the plus sign. You can always multiply it back out to check. X squared plus 2x minus 4x, that's negative 2, minus 8. Looking at the next one. I know my first term is y. I know that I need multiples of 4. So that's 1 and 4, or it's 2 and 2. This tells me that the terms are the same. This tells me that they're both positive. So 1 plus 4 does not equal 3. 2 plus 2 does not equal 3. What does that mean? That means that there is no solution here. This is prime. It means that we cannot factor it. All right, taking a look at the next one. Here we've got two different variables going on. I know my first terms are r. Then if I start looking at factors of 12s squared, I'll just look at the 12 first, right? So I have 1 and 12. I have 2 and 6. I have 3 and 4. I know that this plus sign tells me that these are the same sign. The minus sign tells me that they're both negative. Right, because a negative times a negative will give me a positive. So I start combining these. Will negative 12 and negative 1 give me negative 7? Will negative 6 and negative 2 give me negative 7? Will negative 4 and negative 3 give me negative 7? This is the pair that I'm looking for. Now, I do need this to be r times s. So what I've noticed is that I don't have any s squareds happening in the middle, which means that each one of these will get s. If I multiply it out, r squared minus 3rs minus 4rs, that's minus 7rs, plus 12s squared. Here's the last one. Now I can't split this 2 up because 2 is a prime number, which means that one of my terms will be 2m and the other will be m. I know my last term absolutely has to be 1 because 1 times 1 is equal to 1. This tells me my signs are different. This tells me that the larger value is negative because it's got to be negative. So what I do is I place them and see if it works. So 2m squared plus 2m minus 1m, that will give me a positive. That means this one's positive, this one's negative. 2m squared minus 2m plus m. There's my negative m minus 1. Now it is possible to find greatest common factor and least common multiple, not only of terms, but of polynomials. So really I'm looking for just the greatest common factor, and here are my two polynomials. So the first thing I need to do is factor these polynomials. So if I factor this, I end up with 6y times y minus 1. Those are the factors. And then if I factor 4y to the 4th minus 24y cubed plus 20y squared, I know that I can factor out a 4y, and that leaves me with 4y squared. That leaves me with y squared minus 6y plus 5. Now I am not done here, in case we were curious if we were done. We do have to pull this out into more factors, and this one, by the way, as well. So the first one is really 2 times 3 times y times y minus 1. Here I need to factor the y squared component. The plus sign means that they're both the same. Both have the same sign. This minus tells me they're both negative. So when I write this out, I get 2 times y times y minus 1 times y minus 5. Greatest common factor, circle all the things that are the same. We have a 2 in common, we have a y in common, and we have a y minus 1 in common. So our greatest common factor is 2y times y minus 1.